We live surrounded by answers. We check weather forecasts on supercomputers, track distant galaxies with orbital telescopes, and rely on equations to predict how matter behaves. It is easy to assume that we have successfully mapped the edges of reality. But strip away the laboratories, the textbooks, and the electric lights. Imagine opening your eyes to the world before a single explanation existed. Long before anyone calculated the speed of light or the orbit of planets, human beings looked upward and experienced the only natural response to existence: absolute astonishment. Without the vocabulary of physics, a strike of atmospheric plasma like this is a terrifying, raw display of power. In a world with zero context, the sky doesn't just produce weather, it produces a direct and violent mystery. Every aspect of human existence carried that same weight. The sun returning after a long winter, the migration of animals, the sudden deterioration of an elder. These were events observed with zero context. Our ancestors lived entirely inside a vacuum of unanswered questions. Civilization has spent thousands of years gathering answers. The question we must ask now is whether accumulating all those facts actually eliminated the mystery of reality or simply changed its shape. You can see the origins of our drive to understand reality in any newborn child. Before language or culture takes hold, an infant instinctually grabs objects, studies faces, and tests gravity. The urge to investigate is a biological default. Modern evolutionary biology points out why this happens. In prehistoric environments, an organism that actively explored its surroundings found new resources. The individuals who investigated a strange sound or tasted a new plant adapted to changing conditions faster than those who stayed put. That impulse to test and manipulate the environment directly yielded our first physical adaptations. By studying how different materials shattered, early populations learned to fracture rocks into precise, sharp edges for hunting and building. When you trace the line from those early hunting camps to modern agricultural networks and global shipping routes, you see that the massive infrastructure of human civilization is a byproduct of our innate biological compulsion to poke at the unknown. Eventually, our cognitive capacity expanded. We stopped asking only where to find food and shelter and began asking questions that offered zero immediate caloric advantage. We asked what happens after death and what holds the sky in place. The complex mythologies and pantheons of ancient cultures were early attempts to categorize the mechanics of existence. By developing elaborate stories and formalizing them into strict, structured records, early societies built their first working models of how reality functioned. The ancient storyteller mapping constellations into gods and the modern researcher mapping the human genome are standing on the exact same foundation. Both are attempting to answer the question, why? This shared origin was explicitly acknowledged by classical thinkers. Greek philosophers like Plato wrote that philosophy itself begins in wonder. Across ancient intellectual traditions, there was a recognition that before you can seek truth, you must first admit you do not have it. The pursuit of knowledge demands that certainty ends. That exact sense of profound astonishment has catalyzed our greatest leaps. Observing the bizarre variations in finch beaks across isolated islands drove Charles Darwin to deduce the mechanism of natural selection. Staring at the faint, inexplicable glow of certain rocks pushed Marie Curie to uncover invisible forms of energy, exposing the atomic mechanics of the universe. And wondering what the universe would look like if you could ride alongside a beam of light led a young Albert Einstein to the theory of relativity. These breakthroughs are rarely the result of cold calculation alone. The empirical process is rigorous, but the spark that initiates it is exactly the same sense of awe experienced by our prehistoric ancestors. This diagram shows a core paradox. As knowledge expands, we expect the mystery to shrink, yet gaining facts never reduces the unknown. Because knowledge grows as a volume, the perimeter touching the darkness grows. Every fact increases our contact with things we don't understand. We mapped the billions of neurons in the human brain, identifying the exact electrochemical signals that jump between them. But mapping those physical mechanics only created a much harder question: how those electrical impulses synthesize into memory, love, and self-awareness. We built colliders to look at the smallest possible scales of matter, expecting to find solid, predictable building blocks. Instead, we found a realm where matter behaves like waves, and absolute certainty dissolves into a haze of probabilities. The deeper our instruments look, the stranger reality becomes. Science is an engine that generates answers, but it actively produces profound mysteries at an even faster rate. To understand why we investigate reality, we have to pull back our perspective entirely. Looking out at the stars of the Milky Way, we have to remember that we are part of this system, not separate observers. Through gravity and pressure, raw atoms clustered together to ignite stars. Inside those stellar cores, heavier elements were forged and scattered. Eventually, those elements assembled into biology. That biology developed complex nervous systems, which grew into brains capable of conscious thought. And that consciousness began to look upward and ask questions about its origins. When a human being looks through a telescope or writes an equation, the physical matter of the cosmos has finally reached a state where it can observe itself. Human wonder is the universe becoming self-aware. And perhaps that is the deepest mystery we will ever face. Of all the possible ways the laws of physics could have unfolded, they somehow produced a reality that hungers to understand itself.